Let's imagine you had any old circle and you decided to inscribe an equilateral triangle. Well, then I have a question for you. What's the probability that a randomly chosen chord is longer than one of these three? Well, you could pick a randomly chosen chord, boom, and you could ask that question, but let's first talk about some background. What if I took two congruent circles and I made those circles there so we'd be sure to have the center of the circle? Well, can you notice there that the radius of the circle is exactly cut in half by the chord of your equilateral triangle? So I suppose we don't exactly need these two circles to highlight that picture. That radius, and in fact every radius, is exactly cut in half. So what happens now if we take our chord and let's just imagine we're looking at the midpoint of that chord, okay? Let's see what happens if I rotate that, keeping the chord the same length over here. Well, if the midpoint of the chord is on that half of the radius, then obviously the chord is shorter than the length in question. But if the midpoint of the chord is on this half of the radius, it's obviously longer than that chord. So I guess half of the time the chord is going to be shorter than my side of my equilateral triangle, and half of the time it's going to be longer. It's 50-50, right? Right?